And welcome back to the Op Show, where we bring you the trials and tribulations, the automations and collaborations from the world of DevOps and the greater developer experience. I'm your host, Tristan Pollock, and in our best show yet, we have Daniel Hochman, platform engineer at Lyft, creator of Clutch. Welcome to the show, Daniel. Really excited to talk about everything open source and the Lyft engineering team.
Thanks for having me.
So give us a little bit of background on just, how you ended up as a platform architect at Lyft, creating, how you got into the open source community, how did you get into code originally?
Yeah, so, I enjoyed playing with computers growing up, obviously. I do remember formatting my entire hard drive on accident when I was 5 years old, and then I had to figure out how to fix it. So that kind of got interest in computers and everything. So when I went to college, when I went to the University of Texas, I was originally slotted to go into the computer science program, and I remember showing up on during orientation to take an entrance exam to try to level you into a certain class. Which classes are you going to start with? Basically, what foundation do you have? And the questions on the test didn't make a lot of sense. Like they had a lot of just strange language, and I don't know. So I went and asked one of the proctors, what does this mean? Is this question talking about this or that? And she said, well, I'm a theater major, so honestly, I really don't know. And basically, I found out that the computer science program at that time at the University of Texas was in the College of Natural Sciences, meaning you had to take biology and all these kinds of classes that don't really fit with computer science. And the program wasn't quite as highly ranked as the engineering school. So at that point, I just decided, okay, the engineering school is a top 10 engineering school. I've always been interested in computers in general, so let me go and study electrical and computer engineering. So my college career was largely focused on learning about hardware and embedded systems. And basically, my junior year, I took a 1-hour elective in Perl. Prior to that, I'd only written code in C and Java, and maybe I took a data structures course in Java. And that 1-hour elective basically just ignited my love for writing software, because Perl, while it has many problems, they call it actually like a write-only language. Like once you write the code, you can't actually read what you're doing, but it's really fun to write. There's a lot of like magic in it, basically, where you can type a couple characters and get something out there. So I just fell in love with programming at that point due to Perl. It was just really quick to write programs. You didn't have to worry about types. It was the first like dynamic language I had worked with. You could just get scripts going really quickly. And that just was so much more powerful to me than Java at the time. And of course, Java and those languages have improved a lot since then, especially the tooling and IDEs around them. But yeah, that 1-hour elective pretty much changed my direction from embedded systems back to software engineering. And I had an internship, and stop me if I'm going on too long about kind of the...
No, that's great. Yeah, I always like to hear where people come from, and half the time we get people playing instruments. I see you have a guitar back there. Maybe we'll get a little taste at the end.
Sure. So yeah, I had an internship at ARM. I was working in the DFT department, which is design for test. So I was working, on physical silicon, and I just decided that I didn't want to do hardware. I wanted to do software, but I couldn't get a software job. Just with my experience and my internship, it was not really geared in that direction. And, I was living in Texas at the time. It's not like I was in the Bay Area. So I actually took a job doing kind of technology consulting with a firm, and it was almost management consulting, and that was just an easy. They'll hire anyone with a little bit of charisma, basically. Not that I necessarily have too much, but so I was able to get that job, and that job involved 100% travel. So my initial client was in Detroit, then I was in LA, and when I was traveling to LA, first of all, the client that I had gotten on was not a very good client, so I was kind of looking for an out. But I was also just tired of traveling from Texas to LA so much. So one of the people that I went through orientation with was looking for a roommate in San Francisco. Orientation from the work orientation, not from school. So, he was from the Bay Area, so he knew all the, neighborhoods and microclimates of San Francisco. So yeah, I moved to San Francisco at that point. I was still working in LA for a little while. And then I started looking for a software job. Once you're in San Francisco, there's just...
You don't have an option.
You go to a bar, you go to a coffee shop. It doesn't matter. You're going to hear people talking about technology and, all these startup companies and everything. So...
what was the neighborhood that your friend...
Yeah, it's time to make the leap. So I got a job at like a small solar company. It's an engineering team of about 10 people. And I was mainly doing like QA framework development and writing a lot of Python at that point for QA engineering. That was kind of their biggest need, actually. And, again, small software team. The company was very much sales driven. So, they have 10 big contracts. Someone says they want a feature, who has one of those contracts, like, you build it. So it was a really interesting, clean energy is a very interesting sector to work in. The company itself was interesting. I met a lot of really cool people through that. And I learned a lot just, about writing Python and going through all the steps of kind of building these test frameworks from scratch. And then one day I took a ride on a Lyft, and about 4 months later, I was working there. So I was, looking for, a new job, and I saw one of those pink mustaches. I figured out what it was, I think a few weeks later, downloaded the app and arrived at Lyft. And at that time, I think there were about 20 engineers or so, which includes, data science and some of the management roles potentially. So very small engineering team, very early, and Lyft itself was gaining a lot of popularity, but the company was still relatively small. And I got very lucky, right, that I got in at that time. I didn't know how to pick a star. I wasn't picking it based on whether or not I thought it would go public or be a huge success or something. I picked it based on the people that I met during the interview, the energy I felt during the interview. Like my interview was during lunchtime, and I remember walking into the front door, and it was like a train station. I mean, there's people buzzing back and forth, and dogs running around, and everyone just seemed really happy. And I was interviewing a couple of other places at the time, and didn't really get that. So I knew pretty quickly after encountering Lyft and meeting some of the people involved with it, as I'm sure you know, that this was a company that I wanted to work for. So went to the interview. And managed to pass it, and then didn't really know what I was getting into, but it's been a great ride. So do you want me to just keep talking about my trajectory at Lyft the last 7 years that I've been there, actually, or you want to switch gears a little bit?
Wow, what a ride! Yeah, so 7 years. So it was probably like 2012 then when you first started working at Lyft?
Well, I guess I'm just under 7 years. So it was 2014.
Okay.
And Lyft itself, I think it started in 2012 from the original concept, which was Zimride. And so I kind of felt like I was in the second wave of people. There were a lot of original Zimride people basically at the company in engineering still. And I really felt like I was kind of the next wave of engineering people that joined the company.
Yeah. I mean, looking back too, I feel like, making that decision based on the culture and, as my partner worked there for a long time. And I think it's a really unique thing. Like even within Silicon Valley and San Francisco, like, maybe you have also like Airbnb, but you don't have a lot of offices or like teams or company cultures that are quite so like welcoming and empathetic, I feel.
Yeah, I remember actually being really enamored with Netflix. The culture deck was going around quite a bit at that time. People were really talking about that, and but I didn't want to commute to the South Bay. I wanted that 10-minute bike ride to work, and so I refused to look for a job, outside of San Francisco proper, because I didn't want to have to take a shuttle or anything to work.
Mm-hmm. And so then you started in the QA realm.
Sort of. I was brought on as a, quote unquote DevOps engineer.
Okay.
And that one other person started the same day as me, who was a DevOps engineer. And then there was one other person that was kind of running all the infrastructure, and he had one contractor. But, I started in January, and New Year's is Lyft's biggest night. We always break traffic records on New Year's. Halloween being kind of the second biggest one. And they had just spent a month spinning up servers by hand, like the original person and the contractor, in order to meet the demand. So the first thing, I just came in, and the first thing we said was, okay, well, we need to fix this, right? We need to automate this. We need to make this horizontally scalable in some way, so that we can click a button and add capacity rather than spending all of this time doing it manually. So yeah, I mean, it was, again, Lyft had a fair amount of funding at that point, had a fair amount of success, fair amount of traffic, but it's still very early in terms of just the maturity of the overall infrastructure, which makes sense, right? I mean, you attack the kind of the problem that's in front of you, the most important one. And but that New Year's was really, I think, a turning point for a lot of people. And when I came in, there was this realization that was something that we wanted to improve. So, the first 3-4 months was just, we rewrote the configuration management entirely, because it's just been an evolution of an older system, and it wasn't great to use. So that was the first thing. And then, the next thing I worked on was actually test frameworks, because there was no automated testing at that time, outside of basic unit testing. So I worked on an integration testing framework that would, create a driver, create a passenger, and actually get them to communicate with each other, take a ride, do those things, because previously, they were relying solely on manual QA for, finding bugs in that kind of flow.
Yeah.
And from there, it was just the same thing. It's like, what is the big problem? How can I solve it? So we had one database, and it was falling over because it had all of the data in it. And the highest throughput data at Lyft, as you might imagine, is location data. So we're getting just thousands, tens of thousands of location updates per second from our drivers and passengers. The way the app works is just polling every 5 seconds to see who's nearby, what's the latest status, did I get a ride? And so I started to look at moving that data outside of the core database. And learned a lot about geospatial indexing and it was just really cool stuff to work on now, looking back on it, and a lot of the stuff that I built back then, still powers some of the core infrastructure today, at least some of the core patterns. That's something that I'm really proud of. But I do remember, I did have a bit of the imposter syndrome, that you hear about. We invited some people who had a much richer background in geospatial, technology and stuff into the office, and I would whiteboard for them, this is how we're doing it, and this is how I built it. These are the problems that we're facing, compromises that we've made, and they would all just kind of go, oh yeah, that works. And I felt like there must be a better way to do this, but again, it's scaled really far. It's worked really well. So I've been very happy with that, and the opportunity to work on that problem, something that powers the core of Lyft, was really eye-opening and taught me a lot. From there, I had introduced Redis and Dynamo to Lyft before we were just using MongoDB, and other teams were starting to take notice. There's I want to use Redis, or I want to use a different database than the core database, right? For faster iteration, they're working on a microservice, whatever that is. So then I founded the storage team at Lyft, basically figuring out how to, even though all the storage is hosted, right? We're using hosted Redis, hosted Dynamo. It's not as simple as just kind of plugging it in, especially when you're dealing with high throughput. You have to set a certain amount of constraints. You have to have infrastructure as code for provisioning. You have to have docs. You have to make sure that you do things in a certain way. So that was the next year or so of my career at Lyft, was kind of evangelizing those new databases and helping other teams, kind of find that lightning rod that I did on locations, where it's like, okay, well, we can start a new code base, we can start with a new microservice, and we can get all the benefits that come from that. And then from there, maybe around the time that I started on the storage team, or a little bit after, we had Matt Klein, the creator of Envoy, join the company. And if you're not familiar with Envoy, it's a proxy similar to Nginx or HA proxy, and just has been on a tear. I mean, it's a huge open source project, just absolutely massive success. And so, Envoy, he was working on it. after the open source, I remember, I was just like, I want to learn more about this space. I want to be part of open source. I want more exposure to this. And so I want to go on that team and get the opportunity to kind of learn from him and do a bit lower level programming as well, actually. I was writing, again, a lot of Python, doing a lot of like data modeling and higher level stuff after locations, but I wanted to get back to writing code. And, and again, and high throughput's always been a thing that's been super interesting to me. So networking is a great place to see that. So I was a maintainer on Envoy for a while, learned a lot about open source and what it takes, and just tremendously valuable experience. And then you start looking for the next problem. And
how big is the team at this point? That you 20 engineers to?
Yeah, you're talking about today, or maybe at the time that
at that time, if you can remember, or if not today.
Yeah, we were probably at 800 engineers or so. I mean, now I think we're over 2,000.
Wow.
So that's, from 20 to 2,000 is 100x growth.
Yeah.
Definitely an interest. When you're all in the same room, it's very easy to communicate. It's very easy to know what's going on. I mean, I knew probably how everything at Lyft worked from a software perspective, and most of the business side too, as well, just through exposure to being able to eat lunch with literally anyone from any team at the company, because we were all in one office at that point. And you go from that to walking around the office and not really recognizing half the people.
Yeah,
it's a big change. And but the core culture of the company is still there. There's new and exciting challenges that come with that kind of growth. I tell people that the organizational growth is actually harder to contend with, I think, than just the scaling problems. It is just a whole different class of problem when you're trying to communicate and you're trying to orchestrate all these microservices and you're trying to remain agile and respond to competitive pressure. And it's I've just, my career at Lyft has been so different from then to now. I mean, it feels like a lifetime ago. And I feel really fortunate that I was able to join the company at the time that I did, not knowing what I was, not trying to get into that situation, but just kind of feeling that energy and that vibe and kind of going after it. And there were other competitors that were unsuccessful. There were other competitors that had other other cultures. It's just, I'm really thankful that I had the opportunity to be a part of that journey. And again, Lyft still scratches the edge for me. I mean, it's still a great place to work, and I get to work on really interesting problems. And I guess now I can kind of focus on, what I'm working on now. So reliability, is a hugely important thing. The core of Lyft is actually about trust. Do you trust that when it says the driver's 3 minutes away, that they're actually going to pick you up in 3 minutes? Do you trust that they're going to drive safely? Do you trust that, the price is reasonable? Do you trust that when you click the button, you're not going to get an error? Like, as soon as you erode that trust in any way, people switch to a competitor. They might not come back. They might delete the app. So it's very important to be highly available with today's app landscape, right? People can just switch to another app. Mm-hmm. And that can be enough to just erode that trust in their mind, such that they don't come back even, or maybe they come back less. So being highly available, super, super important for Lyft, and was always a focus of my work, right? When we're doing a database migration. At that time, we were actually, I remember we would some nights at 2 a.m. take Lyft down for 20 minutes to do database maintenance. And that's unimaginable. I mean, you still have people coming from airports and taking rides. There's still a lot of traffic going on at all hours of the day. Now that Lyft is kind of this 24/7 thing that's, in all these different cities. But back then, you had maybe 10 people taking a ride, at 3 a.m. or something. So, availability again, super important. Reliability, super important, and that's something that we always keep top of mind when we're developing software, trying to make improvements, trying to understand what's going on with errors. So, when I looked at the reliability landscape at Lyft, a big part of it is the design phase, right? Okay, can we advise someone on the right data model, such that it's not just a ball of spaghetti that's impossible to debug or very error prone. So that's where it starts. And I worked on that for a long time at Lyft, data modeling and stuff with the storage team. On networking, one of the big things about Envoy is that it's observability story. It emits tens of thousands of stats per host. And that gives you tremendous power to look across your entire infrastructure with these homogeneous stats and kind of see what's going on. And so, we had this observability revolution, if you will, I think, when Envoy was deployed and as we were doing microservices. The company had always been very data-driven, but that gave us a whole new appreciation for, being able to kind of, dig in on infrastructure and figure out what's going on, figure out where, when you have microservices and you have 10 hops between services to serve a single request, it gets very difficult sometimes to figure out where the origin of the problem is. But anyways, I looked at reliability again from a higher level. I looked at all of the pages of Lyft. I went and scraped the PagerDuty API and grabbed big old CSV. And I wrote a Python script to try to categorize the alarms and figure out what they were. And I think 20% of our alarms at that point were something where basically we would have a problem, we would page an engineer, and we would send them somewhere to click a button to resolve it. And I've been out before with on call, right? You're just getting page after page, and it feels like you can't take a breather. And yeah, I thought, well, if I can eliminate 20% of all pages, that, or at least make it better in some way, that's going to be really powerful, I think, for just quality of life for engineers. So the original idea for the project Clutch was actually an auto remediation tool. My goal was to click that button automatically, and if we couldn't, defer back to an engineer. But the reason why we didn't do automated remediation at that point is because it's a very hard problem to get right. For example, the most common alert was high CPU on a single instance. Now, if that's an outlier within a cluster, sure, you terminate it and it's fine. All of the rest of the instances will take traffic. A new one will come up in its place, via auto scaling. But let's say that all of the instances have high CPU. It could be due to a competitor outage. It could be due to a bug. If you terminate all of them, then you're in big trouble. You're going to have a hard time coming back up. So there's a lot of safeguards and caution that you need to take basically when doing automated remediation, because you can quickly, it can spin out of control and it can do the wrong thing. So started, working on that and figuring out, well, okay, how are we going to, employ these safeguards? And the end goal of the project was to build a platform, right? I don't want to be writing all these remediations myself. I want to give people the power to write their own remediations. Mm-hmm. And, okay, well, if I'm writing a script that's going to terminate an instance, how am I going to get the safeguards that prevent me from doing it across all of them? Or if I'm working on some other resource, how am I going to give me the safeguards that make sure that remediation doesn't spin out of control and just kind of terminate everything or make changes to everything when it's trying to fix a problem? And I thought, okay, well, we could have a library, that people import or something. But just the more I thought about it, the more I realized that we just kind of need an API actually that will enforce these safeguards. And then people can call into that API, right? And then I can write a bash script that does remediation. Then I can write a Python script that does remediation. I can write a JavaScript that does remediation. That's the nice thing about, kind of doing these out-of-band services is that, you can be language agnostic, and that's the goal of a lot of the projects that we work on at Lyft. With Envoy, one of the reasons it's so popular is because it's not a library. It took a lot of lessons from Twitter's networking libraries, actually, which were all in Java, and brought them into this new architecture where it's running on a process, and you don't have to worry about what language you're talking to. You can just talk through Envoy networks. Anyway, so we decided that we're going to build basically an API for infrastructure, for interacting with it, that has safeguards, because I can talk to the AWS API all day long, right? That's very easy to integrate with. There's an SDK for every language. But how am I going to implement a safeguard in that? There's nothing. I can't deploy my own code into Amazon, that says, well, only allow each user to terminate 10 instances per hour or something, or system user to do that. Mm-hmm. So started building that API with the goal of doing auto remediation, and we needed a UI as well. to, be able to see what was happening. Again, if these terminations are running, if something goes wrong, you need to be able to quickly go to a UI and see, is the tool doing something? Is it the fault of the tool? For example, if we see an entire cluster get terminated, what exactly is going on there? So I hadn't really done UI before. I started learning React and all of that. And I decided, well, while I'm here, why don't I just build like a manual workflow? Then I don't have to actually build any of the safeguards. I can start developing my API that interacts with infrastructure. I can have this manual API that's way better than the console, the Amazon console that we were using for this particular use case. And the project kind of snowballed from there. And while it was originally intended to be this, what we originally called it the automated, the ad hoc infrastructure manager, is in most infrastructure is automated via infrastructure as code, but you can define a cluster in infrastructure as code, but you can't go and terminate a single instance in instance as code, right? That's like a dynamic property of the online infrastructure. And that's an ad hoc action. So we call it the ad hoc infrastructure manager, or some people call it the ad Hochman infrastructure manager after my last name. We were doing, we were building these infrastructure workflows, but very quickly the scope exploded. Like people were like, oh, like this is amazing. I have a tool where I can interact with like all kinds of different Lyft things in it. Like I want to add a dashboard, that can like view cost information and efficiency information. So that's our new charter, is to basically build a developer console for engineers at Lyft, and again in open source and hopefully through the industry. We did a lot of analysis on whether or not we could find an existing tool, what our options were, and we really felt that there was a kind of a gap in the market in this space, and started working towards open sourcing it and again increasing the scope. I'll let you ask some questions, and I've been rambling quite a bit, and there's a lot that I could talk about, but
yeah, no, I love the
interesting facets of it, with the open source, the project itself, the engineering team and the dynamics of infrastructure and product and all of that.
Yeah, I think it's really interesting hearing like this, as your story as Lyft is scaling and growing from 20 to 2,000 engineers, and then looking at all the, tackling these different challenges as you get with this scale. I'm guessing like Envoy and was that kind of you're opening your eyes a bit to this open source world, and like, and moving from just building this internal tool to then actually open sourcing it? Or like, talk me through how you kind of, decided to go down that path, beyond just fixing the problems for the company.
Yeah. At this stage of Lyft, any problem we solve requires a lot of investment. If we're going to build something, again, we're building for a big team, we're building for high throughput, we're building for, a certain level of scale that's going to require, more investment than just like building a proof of concept and calling it a day. We've had projects like that in the past, right? Where we built some kind of dashboard and then someone moved on from the team and, it kind of like rotted away and, never really realized its full promise, and eventually just became like this thing that we needed to decommission. So now when we're building stuff, it's like, well, if we're going to do it, like, we need to make sure that we're actually thinking far ahead, that we're thinking about, even more scale or other use cases, and how we can kind of adapt to that. And so when you're doing that and kind of, building with that scale in mind, again, there's a lot of investment, but, also you shouldn't do that if there's an open source product that basically fills the same need, because you're already getting, a tremendous amount of resources potentially in open source. You have a partner basically, that's trying to solve some of the same problems. But yeah, I mean, deciding to open source is actually pretty hard. So, you can Google Matt Klein's thoughts on this. He's again the creator of Envoy. His thing that he'll tell anyone if they come to him and say, "Hey, I'm thinking about open source," is that you need to be prepared to win some segment of the market, right? Like there's no point in open sourcing just to open source. If you don't think you're going to build an ecosystem, if you don't think that you're going to get external users, if you don't think that you're going to get contributions, you're going to spend an inordinate amount of effort basically on docs, on maintenance, on abstractions, and we can talk about that in a minute, like getting something ready for open source. And if you're not thinking about like, well, where do I fit in the market? Are there other products out there? Again, you should probably be using them if there are, but are you really going to open source if you're just going to be, a drop in the bucket or something, if you're not bringing something novel to the space? So, again, we looked around quite a bit at different tools, and we really thought that Clutch brought something new to the market that, none of the existing tools that were out there solved. And, but there was, I just still remember internally, even when we had kind of started to do the calculus and make the decision that, okay, we want to open source. The second that you start enforcing abstraction, people get a little uncomfortable. So in other words, I can't do something that's only going to work at Lyft in the tool, right? I can, right? In some ways, a big part of Clutch is like extensibility and being able to have private plugins and public plugins. But like, let's say for the core, right, which is all that Clutch really is that's the power of it, is kind of the foundation, that API that we talked about, this infrastructure API, the safeguards that it's going to give you, all those different tools for doing the integration. If you try to start making abstractions, it's a tax. It's a tax during development. You have to start thinking about things in a way that extends beyond your immediate use case, that extends beyond Lyft, and that's really hard to do. As a matter of fact, like I spend a lot of time. Probably I would say 10% of my time is just reading what other people are doing at other companies. Same thing for pseudospatial indexing. Same thing for infrastructure as code. You're familiar. I guess that's your whole goal with this project, right? Is to give people exposure to what's happening elsewhere, right? How can we all kind of like learn about the state of the art?
Mm-hmm.
Maybe think about things a little bit differently, or see it from someone else's perspective, and use that to inform our solution. So I spend a lot of time already thinking about that, but now it's a different thing to actually take that forward to implementation. So you need both, and people struggle with that. Trying to make something abstract and generic in a way that works for many different use cases, and you're not going to get the abstraction right every time either. Like actually, Clutch is a rewrite of AIM, and a lot of the code was carried forward and cut and paste, but we rewrote the core to be way more extensible and pluggable than the original, which was a proof of concept, which did have some of these ideas, but didn't really execute correctly on them. But that was the leap that we needed to take to get to open source. What was this kind of big refactor? And it took a long time. People were like, well, why are we not getting new features while you're refactoring? So it's really tough. And again, you have to have a certain amount of conviction and belief, and you have to have a goal in mind when you open source, that you're actually going to make your mark in some way. The other funny thing that happens is that anytime you open source, it's almost guaranteed that someone else is going to open source something similar at the exact same time. We had it happen with Confidant. We had built, it's a secret keeper that we use to store credentials at Lyft. We open sourced it, and I think the same week, HashiCorp open sourced Vault. And Vault is this huge, tremendous product. HashiCorp obviously has a lot of but we didn't even know about it ahead of time. Like we had no idea that they were coming out with this. If the timing had been different, maybe we would have just used Vault at Lyft.
Right.
But it's funny, it's a lot about timing, and it's very funny how that happens. So, and inevitably, when you are solving one of these problems, someone else is probably having the same problem. That's the realization that I had at Lyft, and being in the Envoy community and having exposure to all these other major tech companies. Envoy has just, if you look at the list of contributors, it's basically any tech company you've heard of is using Envoy or migrating to it. And I remember, the first time we met with, I'll just use this as an example. I don't remember if it was actually there, but the first time we met with Netflix engineers, and we were talking about this problem that we were having, and I thought, again, early on in my career, I was like, oh, Netflix has it figured out. They're huge, in open source. They do a lot of publishing on their blog. They're really looked at as a high standard. And we were talking to them about this problem that we were trying to solve, and they're like, oh yeah, we have the same problem. We've made some inroads into solving it, but it's a problem for a reason. It's not like there's just something that we can do and it's fixed. So that's what happens in open source, and that's what you're trying to capture is there's a problem space that's not addressed. You're trying to find some slice of that market. and find other people that need that, and build a community and get that benefit of being an open source and having other people contribute. And yeah, it's like I spent 3-4 weeks like writing docs. There is a lot of investment that goes into open source, but you have to do these things if you want to stand any chance of success.
And how do you, one thing that always is interesting to me, I'm a big fan of the open source community and what that's created. How do you think of it? What sort of sign-offs and, strategic decisions you have to think for the business as you, potentially open source something that could be a strategic advantage for Lyft in a very competitive market? How do you think about that process? And then, do you, and then also have the time to reduce 3 to 4 weeks of docs?
Yeah.
Do you have kind of like a Google, like 1 day a week, sort of 20% time, or talk about a little bit about, I guess, how that looks as like from like a business perspective, and how you kind of were able to continue moving this to open source while maintaining Lyft's competitive advantage.
Yeah. It's you have to have a problem that you're starting with, and everyone at Lyft was frustrated with these on-call alerts that we were getting and our inability to like make any progress in solving them. And there's a number of other problems that we were trying to solve. That's just kind of the most prominent example that I can think of. Mm-hmm. But at Lyft, engineers do have a lot of agency, and that's the power of these companies, right? It's not like that first software engineering job I had, where it's contract driven, where there's a salesman and the salesman sells a feature and then you build it. The reason that Lyft is so successful, and the reason that these tech companies are all just able to grow so quickly, mm-hmm. is because they empower their engineers to make decisions, to find problems, and to solve them. And so, yeah, it started with a prototype that didn't take more than a few weeks or something, right? But once you kind of get that going, then you have a lot more latitude, and you need to be showing progress and demonstrating progress. But it solves a problem, right? So you have other teams that want to build tools but don't have like UI experience. That's a very common thing in infrastructure. Personally, I bounced off UI development, JavaScript and stuff, 5 or 6 times in my career. Big part of that's I never had anything to build in it. But I think React and stuff is also really, really nice and really helps people get going quickly. But even in Clutch, we built some abstractions on top of React that make it easier to do some very common, things, so that I don't need to know what a React hook is in order to implement, this kind of flow where I don't need to know all those internals. We try to give real like semantic meaning to the code that you're writing for the front end. And that's part of the power of like JSX and React, is that when you read it, like the name of the component, like I can literally take a piece of paper and translate it to components, and then I can write the components and read the component. It's very, very readable as compared to like some other abstractions that people have put over JavaScript and stuff. So yeah, that's a big part of it. Is you are still solving a problem, and there are many other teams that are clamoring to contribute to Clutch actually, and it's like sometimes we have to tell them no, like we're still working on the core. For example, one of the things we're working on right now in the Clutch core is asynchronous task management. So in infrastructure, especially, nothing is like perfectly consistent. When I terminate an Amazon instance, Amazon sends a graceful shutdown request. 5 minutes later, the thing shuts down. If I resize a cluster, in Kubernetes, or resize an HPA or something, nothing is instantaneous, right? You submit an update to an API server, the API server acknowledges it, and then sometime later, it actually goes and enacts it. Mm-hmm. That throughout infrastructure. And so that's something that like we're working on, that we need to build for the core in order for other teams to contribute. So you have that piece of it. Now you mentioned like the competitive advantage. How do we retain competitive advantage? Well, I think there's 2 answers to that question. The first is that open sourcing does not give away any competitive advantage in my mind, because truthfully, if I gave you a hard drive with all of Lyft's code on it right now, and I gave it to you, you really wouldn't have anything. I mean, you would have our code, but you wouldn't be able to like start your own taxi service based on that, right? There's a tremendous amount of complexity at this point, of course, in deploying it and getting it working, and it's this own kind of living, breathing thing. but there's this huge team of business people behind it and operations people. And I mean, it takes an enormous amount for a product to be successful. Maybe there are some, engineering things that you wouldn't want to give your secret sauce away or something. But, when you're talking about infrastructure engineering, when you're talking about, some of these general domains of software engineering, there's nothing that's a true competitive advantage. Again, if I give, my competitor that code, it's not in truth going to help them all that much. I mean, there's so much more to actually being successful that, there's no like direct impact that's going to have. And, I'm a big believer in the Conway's law, right? Where it's like the organizations, the software actually ends up mirroring like the structure of the teams. So like if you have a lot of small teams, you end up with a lot of small microservices. If you have a big team, you end up with one big monolith or something. And so, there's a lot of nuance as well in getting these things deployed and running and successful. And so just giving someone the code that we wrote, for X, Y, or Z, it's not going to give away our competitive advantage. There's so much more to it in the culture and the operations and in the branding and the market. I mean, it's a huge thing, right, to have a successful business. Of course, if we're talking about like LiDAR inference or something, I mean, that's a bit more sensitive, or potentially. Some people would probably argue, no, there should be, all software should just be free and open source, of course. I'm not too deep on that, but when you're talking about these general domains, infrastructure management, whatever it is, there is no real competitive advantage. And maybe the other element of your question was, well, what if I went and worked on, locations again, right? And made some improvement on that. You're like, how do you decide to allocate engineering resources, to infrastructure versus products? I mean, and that's an age-old question, right? Because I mean, at Lyft scale in particular, if I make like a 0.1% improvement in some algorithm somewhere, like its accuracy or that can translate to millions of dollars at our scale. But there's this balance. And our product engineers need infrastructure to get their job done. We need to make that infrastructure. Every minute I spend like working on Clutch will hopefully save someone an hour, down the road. When you're talking about 2,000 engineers, like using a tool, if I can save someone 3 minutes, 6 times a day, I mean that adds up to a lot of time. And that's how we approach the problem. We're trying to build things that people actually use. And, it's easy to fall into a rabbit hole sometimes. I mean, we've all probably worked on projects in our career where you get into it and eventually you just think, well, what am I even doing this for anymore? Maybe there is an open source solution and you're still maintaining your homegrown thing. Maybe, it just didn't get as much usage as you thought. Whatever it happens, we all have projects that kind of come and go. You have to be ready, at a certain point to reevaluate. And, that could always happen with Clutch, right? Let's say like 2 years from now, nobody's using Clutch other than Lyft. Is there a reason to continue paying like open source tax potentially and developing? Like right now, when we develop features, we try to do it open source first. And then we layer on any of the Lyft specific abstractions afterwards in our private kind of extension. And the extension model makes that really easy. But again, it's hard to think about that. You have to have awareness of the other people in the industry, what other people's infrastructure looks like. And then you have to translate that into an abstraction that actually makes sense. So, we could develop features much faster if we didn't have to like think about, the open source potential for that. So it's all, like anything, it's all, you're just making a decision and kind of, Lyft places trust in us basically to decide whether or not, that's what's important right now. And so that's what we do.
Yeah, no, I like that a lot. And I feel like maybe even another thing that, you were kind of touching on, but maybe didn't say directly was like, as part of open sourcing too, I mean, the contributor network, if you were able to foster that community, like that will probably see maintenance and improvements to the tool even beyond, where you left it when you first open sourced it.
Absolutely. And there's no bigger proof of that than Envoy. I mean, maybe I don't remember the timeline, but probably within the first year of the project, there were more people working on Envoy at other companies than there were working on Envoy at Lyft. And one example even is like, with Envoy, you're dealing with networking, like security. Security is a really hard, you have to have very deep experts when you're talking about, like TLS 1.3 compliant implementations and 0 day. You need experts in that. And like, those are the kind of people that Lyft necessarily employs, right? So because of that open source community, they get kind of the domain expertise that Lyft has in building this stuff. And we get their domain expertise with like the security stuff that goes on in Envoy.
Mm-hmm.
It's amazing how quickly these people react to kind of the changing landscape, making things more secure, and it's just, you look at Envoy and so much of it is driven by contributors, like way more than what's been contributed by, other than Lyft creating the project and open sourcing it. There's been just like Lyft just daily gets stuff for free from Envoy that's coming in through open source.
Yeah, that's really cool. Well, I want to be cognizant of time and give you a little bit of time, for any, to hear a little bit about any, workflow, productivity hacks that you use on a daily basis, some of your favorite tools, any shout outs you have. So probably over this next, few minutes, lay it on us. Like what are some of your favorite, favorite productivity hacks and tools, and start there.
Yeah, well, I love my my IDE especially. Golang and the IntelliJ tools are really amazing, and just make it so much more productive for me. I think I'm mentoring a junior engineer, and I was talking to her about what are some of the important skills, and the two that I think are, well, the biggest one I think that's most important is the ability to reverse engineer something. And so, being able to like take a stack trace and walk down the stack and figure out what's going on. Like when you think about like Lyft software or any software, nobody actually knows how it works on paper, like, in their head. Like, yeah, I wrote some code in this 6 months ago, but do I know all the changes that have gone into it, all the interactions that are going on, all the libraries that are running in it? You never know. So reverse engineering is kind of to me, one of the critical skills of software engineering that I tell people to work on, because asking someone the question, like, you're probably not going to get the right answer, because I don't think in truth, like, anyone really knows how all this stuff works, beyond like a high level. So being able to answer your own questions, fish for yourself, if you will, and being able to really drill down the stack, no matter what it is really important. Again, I spend so much of my time just reading code, trying to understand how other people did something, or trying to understand how my own tool is working, and interacting with the libraries and stuff. And the IntelliJ, having a competent editor, that indexes all the symbols is really, really helpful in that, because you can just keep clicking in, you can run a debugger, things like that. So, my editor is like critical to my workflow, and being able to do that reverse engineering. The other really important thing is, code search is also, we run SourceGraph at Lyft, and that's like the most invaluable tool. But there's actually an open source installation of SourceGraph where you can search across the top 10,000 repositories on GitHub. And I use that all the time. Again, when I'm looking at some Go SDK and I just don't quite understand what this option does or how it's being used, I'll read the code, try to figure that out if the docs don't tell me. But again, looking at, what other people are doing with this library, how they're solving this. Like, we use this project called gRPC Gateway, which is amazing. And I'll talk about when I talk about protobuf in a minute. But yeah, like so many times I've just gone and looked for a reference in the open source SourceGraph. And the other thing I told her is, knowing regular expressions, because that will just make your searching ability so much more powerful. Being able to kind of like do these fuzzy searches for things rather than just like doing, relying on specific tokens or something to search for. So yeah, being able to reverse engineer, knowing regex, and being able to really just like look across a lot of code quickly, drill in where necessary to understand how something works yourself, rather than asking someone or trying to consult docs that aren't up to date. I think that's really, really important. One of my favorite things in Clutch is that gRPC gateway, but it all starts with protobuf and these interface definition languages. So, we've all worked with JSON, and, these like, there's no typing, or it's just a blob, right? And that's really powerful, right? I can, add keys and subtract keys easily, and I can use them. I can consume that on the other side without having to like write new code. But writing definitions of your interfaces in protobuf and then generating code it's so transformative. Especially like we have our front end and back end, and we use the same definition to generate the code for both. So if we make a change to a field, we don't have to like remember to go update the front end. It'll actually start to like fail to compile because that field is like no longer not consumed correctly or something. And it ensures that you're always backwards compatible. Like being able to generate code from interfaces is really, really amazing. And the gRPC Gateway project takes that a step further, which is you can write gRPC endpoints, defined in protobuf, and then it will translate them to JSON. So I can have a REST API and a gRPC API powered by the same code, and all that stems from this interface definition. So it's amazing because now when someone wants to develop a feature, they start by writing the API that generates some code, they implement the stubs, and then they implement the front. Like it's such a guided process, and it's just a pleasure to like do code review on it because it's very clear like what all the different blocks are. And I really, really love that. And these are the kinds of things that we try to bring into Clutch to make that workflow development really easy, without ending up with like spaghetti code or without knowing much about front-end development. We try to put you on Rails as much as possible when you're developing features, and using all of these tools is kind of what's important.
Yeah, that sounds, I like that. I love your energy about it too. And just like the focus points, like you said, the Rails, the kind of frameworks of it that can make it so much easier and so much faster.
Oh, your video froze. Well, I'm going to do a brief outro here since we only have a minute left. You can check out Clutch at https:/clutch.sh or Lyft Clutch on GitHub. I'm just doing an outro since your video froze. I don't know.
Oh, yeah. No, keep going. Yeah, I'm glad to get
going. Clutch is like an open source. We didn't even really talk about what it was in the promo, but Clutch is an open source tool for building developer consoles, building these workflows that allow you to do step 1, step 2, step 3. Like the way that we're thinking about it and thought about it early on is like, can we build a better AWS console, right? That's more streamlined, and again, make development of those features really easy. So check that out. If you go to my GitHub profile, you can find contact information for me. I'm always happy to talk about this stuff, whether it's related to Clutch, related to Lyft, related to software engineering in general. And thanks for having me on the show. It's great to chat about this.
Of course, yeah, amazing story. I mean, I loved hearing, especially just like what has happened with Lyft since you joined and where it is today, and so happy that you're still loving it and such a great company. So thank you for sharing all that. Thank you for open sourcing, and I'll drop all these links into the description, and that's it for today. So thank you for coming on the Op Show, and we'll see you soon.
All right, thanks so much. Bye.